All well. Can I go?
Yes,
Yeah.
Ankur.
Okay. So Valentine Day is tomorrow, and love is in the air. And what better topic to talk about when it comes to this week? And for us techies, what does it mean to love or hate? So uh, our own techie nerdy twist on love and hate. Let's look at what it means in the C++ context. What I'm discussing today is all about modern C++ and how things uh, uh, are better and better, and what choices to make when you do your implementations. You should love to make some choices and hate to use other options. Okay, so I'll request everybody to go on mute, please, unless speaking. So, love is in the air. It's inevitable. It is inevitable. It is inescapable. And for techies too, it's just the same. The world, which truly is like this, to us, it starts looking like this. It's red and love, love, love. It's everywhere. I hope you all have great plans for the Valentine Day. And with love on our minds, what do? The techies are all pumped up in deep love and thinking about the inevitable love relationships and the hate relationships, what goes well together and what doesn't in our own tech world. Okay, so in our own way, today we will look at the Romeos and Juliets of C++, the Jays and Virus. So Romeos and Juliet just they have to be together. Jays and Virus always complement each other. They help each other. The opponents, the Thakurs and Gabbars, where they just can't stand each other. They are at the drop of a hat. They want to eliminate the other. We have two sides of the same coin with Ram and Lakshman here, and we have the Mr. Indias and the Mogambos of the C++ world. So let's see what, in a fun way, how we can relate to these kind of relationships. Okay, of course, love is in the air, and if you love to be together, I have to mention about STD pair. STD pair is to bring together, bundle together any two things, and they could be anything, basic data types or advanced ones. I'm sure you have all come across this. So STD pair is the easiest way to bundle two things together, and that's how you do it. Employee belongs to a department. You can just have a pair of employee and department. Okay, but just a pair says nothing about what is the relationship, what it means. So if you just take the little pain of just naming the thing by a struct or something, it will be much helpful. It will mean the same thing to many people. For example, just looking at the employee and department pair, I'll just try to bring a pointer. Okay, you don't really know what these two things have come together for. And if you just name it, even if it is just for the name, it is much helpful in having better code. It is error code and error text. So with C++ 17, whether it is a pair or a struct, you can just disseminate it into its constituent elements by using structured bindings. Okay, guys, in today's discussion, I'm assuming a certain level of knowledge and understanding. If you have any queries on what I'm assuming you already know, please just raise it. Okay, so C++ 17 structured binding helps us, handle both these things just to get similarly, and you can just check uh, both the parts, both the parts of the pair, both the elements of the struct separately. You have the standard library which has things like map insert, which returns a pair. It returns a pair of an iterator and a bool. Bool tells you whether you actually were able to insert a new entry, and the iterator is the iterator pointing to the entry that was newly inserted, or if the entry already existed and you could not insert a new one, it is the iterator to the entry which is already existing for the same key. Okay, so you have a pair used by standard library, and it's a very convenient one. It is very adaptive. For example, depending on the types that it holds, it has its operations or not, whether it is movable or not, whether it is copyable or not, whether it is no except or not, and those things depend on the constituent type operations. Okay, so it's a smart way of getting around. Okay. Next, we discuss about decltype and auto. These two really go well together. Our compilers can reduce data types. Okay, both keywords are requesting really the compiler to do so. Enable the implementer, these enable the implementer not to have to specify everything. You don't have to be repetitive that this is the data type every time. And we'll come across sometimes you can't even name the data type. So let's see this. When you have auto I equals 10, looking at the value, the data type of I is known, it is an int. If you have a unsigned long value, you know the UL variable is an unsigned long. Now, if you have a lambda, you have to use auto, and you can define this construct dynamically in code, and it just helps you wrap up some functionality, and there you have a lambda called as close. What is the data type of lambda? This lambda closure has some data type, but you don't know, the compiler, it cannot be named. The compiler just generates it. But you have close, which is one instance of this lambda. Okay, lambda closure. Okay, now if you just want to use it, I'm trying to use, you would remember the session which Shilpa Dodeja took on unique pointers. There she mentioned about using the unique pointer to your advantage, where you use some data type. Now in this case, you want to specify that this is the lambda which will close the file pointer. Okay, we are all aware of the C style file pointer. If you have to use it, this is how you can use it in a C++ way, where it is safe and always taken care of ownership, and the file will always be closed, blah blah blah. So you have the unique pointer, but now you want to specify that you are providing a mechanism to clear up the resource, to free the resource. What is it? It's closed. You pass its instance to the constructor, for sure. That works well. But what is the data type? How do you say what it is? This is where decltype comes in, and you say, I declare the type of close here. And that's how it's using, it's just determining whatever the data type of close was, whatever the compiler created, and it is able to use. Right? More on decltype and auto. So if you want to have, if you have a vector, and if you just want to sum it up, okay, how would you implement this sum? There are already standard library features which do this, but if you have to write something similar of your own, you would do this. You would write a sum function which can pass a container which will total up the thing. But you have the template parameter, which is a container here. And this container contains what kind of a data type? You don't know. Okay. So what you want to really do here is just be very simple. Go through all the elements and just sum them up. Nothing great about this so far. Just beginner's code. And how do you say what is the data type? So there is a data type inside the type vector which says what is the value type. And this value type you want to refer to. and you want to create a variable called as total, which is of that type. And this is where the dependent type comes in. But as you see in the comment, there is an error here. This does not name a type because C is an instance, it's not a data type, and oh sorry, I've written V1 here. The C does not name a type here. Sorry about the typo. So the C is not naming a type here. A type is expected here. And so this is where again decltype comes to our rescue. It becomes decltype C, whatever that type is, and the value type total. Okay, this is an example made to show to you what kind of problems you run into templates. Does somebody want to point out why don't we write container colon value type here? That would be perfect code. That would be right as well. So you have the type named container here. So just wanted to show you how sometimes you don't know the type of something and you have to name it, how you can use it. And all is well. Total starts with 0 and it sums up everything. Again, the return type of this function is auto, and it just determines what it returns. You have to make sure that this entire body is visible, the return statements are visible for auto to be able to figure out what the data type is. Okay, next we go to default and delete. You want to ensure that classes have their semantic meaning. So you want to get the compiler to automate some of these things, and you use these with special functions, special member functions. What does it mean? You have a class called as dbcache. Somebody wants to say something?
Yeah, I think students have some question.
Yes, please. I'm
Hello.
not seeing anything. You'll have to read it out, please. Or Suraj can speak up.
Yeah, can you hear me?
Yes.
Okay, great. So actually, I understand that auto, we basically, it's kind of a smart way to define a variable type or data type. And then you use, what is that? Uh,
Decal type?
Decal type, yeah. So what is the fundamental so I feel like decal type is also trying to fetch the type and then define the variable. That's what it is doing. What is the fundamental difference between, and what about the time consumption of these two operations? Like if I do auto or if I do decal type, which one will take more time and which one will take less time?
Okay. So if the value, sorry, if the data type can be determined, I'm just trying to go back. Yeah, there you have it. So if the data type is determined, you can determine the data type from the value. Okay. Uh, you can use auto. So if here on the right hand side, we knew we were dealing with numbers and 0 was a possibility, then you could write 0 here. But you don't know for sure. Your container could be a container of strings. And what plus equals does is just concatenates all of them. This is what generic code does. It is absolutely similar, just that the data type has to take care of plus equal to. So if you don't know what kind of an initialization value you are providing, and you just want to create the default initialized value, you have to name the type somewhere. And that's where you will need to name the type. In this case, you didn't you are getting a container. So let's say if this container was an auto parameter, okay, it is possible I should have mentioned this as auto. So if you just if this function was taking in const auto ref c, where auto would be actually referring to a container, you don't even have the name of container. Okay, it is simple code for people when they are not seeing a lot of template type name prepending appending the functions, qualifying the functions. So if you just say const auto, which is going to do the same thing, determine the type of what is passed. So here v1 is passed, it becomes vector of int, and so you don't even have the name for the type. In that case, you will definitely have to say decltype of C, just the same type of C, and then you use it. If you have the type determined by some other value, maybe most probably the right hand side, but maybe the initialization value, then you can just say auto. Like you have for auto X in C. It goes through every element of C and it knows what the data type is. The compiler will figure out. And so because there is a value, there is already type of values inside this container. But here you are starting with, you don't know what value, you just want to default construct it, and you don't know what the, so you can't name it. So that's where you say the type which C has, colon colon value type. Okay, and both these constructs have zero runtime penalty. They are just things that compiler figures out at compile time. It's a static type language, and in favor of type safety, all of these mechanisms are all determined at compile time. All well?
Yep, thank you. Got it.
Okay.
Sorry to interrupt.
Yes, please.
There was a question in the chat
Yes.
about the deleter parameter of the unique pointer.
Yeah.
It's just a comment that anything which implements operator C brackets with the type of the value that the unique pointer stores can be used to as a deleter.
That is correct. It has to be a callable. The way C++ calls callable is you can use it with the function call note syntax. Okay, and if it's a class type struct type, you have the operator implemented with the right types. If it's a function, you anyway have a callable in your hand, right? We'll have more opportunities on that.
Ankur, actually,
Yes, Kashish.
I was referring to the same question that Ayan has said.
Yes.
He said that can we use standard function instead of declare type in the earlier example of lambda with C style pointer?
Yes. You can use a function, std function, as the name says, is a function object which allows you to wrap a callable. It can be anything. It can be another object, a function, or lambda, or whatever. So it's an abstraction. It's a type erasing abstraction which can hold any callable. So that itself is also callable, and you can use std function for sure. Please note there are some possible overheads with function. If it's important, then you can use function. If you have a mix of different kinds of callables, you can use std function. That's one good reason to use std function. All right, I'll go ahead. You'll have other opportunities. We will discuss about unique pointer ahead anyway. Okay, so we have these directives to the compiler for special functions. Now, if we have a basic DB cache, database cache class, we want it to be non-copyable and only movable. What do? We can the 5 special functions are created by the compiler by itself, and it tries to create them automatically. But if you want to take control, you can just ask for these to be not created, or to be implemented by you, or to be created by the compiler by default. Okay, so these 5 constructs, just in case somebody is not clear, are constructor, the copy constructor, the move constructor, the copy assignment, and the move assignment. Okay, then there is another special function, the destructor, which is created by the compiler. All right. So if we want to right now say we don't want to be able to copy this, you can imagine this cache is huge and you don't want to be able to copy. Maybe that's your requirement. So you just ask the compiler to not generate these. The moment you take control and you ask for these to be not generated, the other special functions, the compiler may or may not generate depending on the case. So it is more likely safe to assume it will not generate. And so you want to ask the compiler to really generate the move operations. Okay, I'm assuming you guys are clear about move. If you're not, there was a talk done by Dheeraj previously in CppIndia. You can refer to that, or we can talk about this on our group in Discord or somewhere. So the move operators help, steal the resources from another DB cache. So you want it to be movable, but not copyable. So that's how you do it. You just ask the compiler to delete the copy constructor and the copy assignment, and to default, which it would have generated if you didn't touch any of these functions. So if you want to ask the compiler to still generate some, it would create these. And as you know, the types here are unique pointer. This is a non-copyable type itself and a movable type. So its move constructors will be used inside the implementation here, inside the operator equals and the move constructor. Okay, and even for vector, it is movable. It is also copyable, but there are reasons why you would want to prevent these, prevent copying, prevent move, which are not in the language. It is the decision of the code base of the implementation. All right, so they often go together. Delete and default, use them to your advantage. Staying with the way you can, the kind of things that you can specify with the functions, you have virtual and override. Okay, they work together to make sure you don't go wrong and at compile time. So let's see something. You have a timer class, you want to start and you want to restart it. Okay, whatever restart means, maybe you start again with the duration. Okay, so as you see, you can have an advanced timer which adds some other functionality, but we are looking at it only with respect to these virtual functions. So you have an advanced timer which also has the start, but did somebody spot the problem with
Yes, the
restart?
second restart has a parameter of duration
It has
in
a
advanced.
different signature than the original one, where you actually did not mean to create a new one. Thanks for that. So how do you save yourself from shooting yourself in the foot? Very easy. If you are at least C++11 in your code base, you can do this. Use restart, which says equal to override. And at this point, the moment the compiler compiles this line, it says nothing matches the signature of a virtual function in the base class. And at this point, I cannot continue. It will just bail out and give, and it will help you go wrong. So if you implement this and you would struggle in the past, why my restart is not working, where just you started passing something to it, you don't have that problem now if you just start doing this. Simple thing in modern C++. All right, go ahead. Let's go ahead. Const pointer against string view. So this is a hate, or a relationship which betters what is on the left. So string view would tend to better const pointer in many cases. So you have consider this code. You have a message called a CppIndia. You want to make a string out of it. Fictitious example, but very often you have to do this. And every char has to be inspected in this because it's a const pointer. You don't know where this value came from. You don't know how much the length is. You have to look at every character and copy character by character into the string. You can't get smart about it by copying blocks or moving memory, or copying blocks of memory. Something like memcopy does, or memset does. Not memset, memcopy. So you can't do that because you don't know which character might just be the null. So you have to stop at /0. This is the issue with the C style things. There is a value which denotes the end of the string, and not the smart type which knows where it ends. Okay. So if you do this, instead, if you start using string view, which was introduced in C++17, you now have a data type which knows its length. It is just this session was covered by Mahendra previously in CppIndia. You can watch that one. It is a data type which essentially is having two things. One is a pointer to data and the length of the data. Okay, and so if you pass a const pointer here, so if you start taking the string view, you already know the length, and while you create the construct the string, you can make smart decisions. You have the short string optimization. Those kind of things can just trigger if you already know the length, and if you don't have to copy byte by byte and allocate memory, etc., by seeing that you are going overflow or not. So you can be much smarter, much efficient with the implementations. Okay, and how is this string view constructed? You pass to the string view a data and string length of data. Now, if you have a C string, you will have to use C style ways of figuring out the length of the string. Okay, so you have to use string length, which will iterate the entire data once, and now you know the value, and now it can be efficient when you create the string. Doesn't sound good. This is what happens when you mix the C style things with C++, where things could originally be smarter. Okay, so we'll evolve this option. We are not stopping here on this. We'll just look at one opportunity of using a modern construct at this point. I'm sure many of you would have thought of hash defining the size of that message, right? And we all have written this code, I'm sure, if you have done any kind of C like C and C++ like mix-up or C code. You have message, you have CppIndia. In the message, you have a hash defined message length which says the length is 9. Now, if you have to pass this to the string view, you already have the length, so you can start to use the string view in a better way, in more efficient way, and you have the message length which is going to text replace this 9 here, and the string view is constructed. And if you note, you don't have to name the type here. You know that the toString is a function which takes string view. If you just have the curly braces, you know which type you are constructing. You are constructing a type, and you know which type you have to construct. And just the constructor with these two, which takes these two data types, the const pointer and the MSG length, and the int will be figured out from the value 9. So that will be called. So now you have the string view created, more efficient. Now you can just be happy about it. Okay, now you are in full control, but you are fully manual. Okay, so we have something in C++ which can help you with this. In C++11, we got constexpr, which helps you run code at the time of compilation. This is not running at runtime, or it can run at runtime, and it can also run at compilation time. So if you have a constexpr function which is get string length, and we are not going to implement this here, we know how to do this. So it can figure out the length of a const char pointer passed to it. So if you have this, now if you have a const expr int message length equals get string length, calling the const expr function, you know it's a constant expression. The compiler has to evaluate it at compile time, because you have qualified the const expr here, your message length as const expr. So this becomes a length which is found out at compile time. No runtime penalty, only a compile time penalty for our need of having to use C style things. Okay, so at this point, if you have this function, just like before, it's a copy. Now you can have something like this, message length. And did you guys spot that the message here is not 9? Length is actually 10. You have the exclamation mark. And if you do manual things, you will go wrong. I purposely went wrong in the previous slide. The length here is actually 10. And it will be always correctly figured out. So please favor programmatic automatic means than donkey work, where donkeys do go wrong. We are donkeys, in a way. Humans would go wrong. So, so this is how you can make life better with modern C++. Choose the better ones. Don't do defines, because One, it is text replacement, and you would have seen why text replacement also goes wrong. If you put a function invocation there, the text replacement of the function invocation would happen n times wherever you have used multiple times uh, the hash defined thing. I'm not going there. I hope you know. If you have any questions on that, we can talk about this later. But automate the donkey work. The compiler is there to do things, even smart things at compile time. Use constexpr. Okay, so now if we come back to see what our solution does to us, now finally the toString helps generically handle many data types because we are using string view. With the definition as this is just like before. The code works for any string-like type now. Okay, so any string-like type would love string view. Okay, so if we now pass MSG to it, we have a convenient constructor already in the string view constructor, which if it takes a const pointer, it will do an str length by itself. And if that's what you want, you can go for it. If that's what you want, you can, if you know the length, or if you want a shorter length, you can pass the length yourself. And at this point, you have a string view which knows that it should only use 3 bytes. And as you see, you can enjoy not having to null terminate, not having to copy it into another data type, and you can just continue to use it like a view. It is view for a reason. So you have the string view part. So you can create a string view which is a part of the message, and of course pass the string view itself. No point for guessing this. That was the data type is the function expects. We have I don't know what's wrong. Okay, so we can have a long string and we can pass the string itself. So string already has a dot length, and string view knows how to figure out the length from an std string. So and it will be as quick as anything. Now, if you want to use a smaller length from the std string, that also will not be null terminated. But hey, you can say that now. That should have been slightly different. You can say string one dot tstring or dot data, where you take the starting pointer and you say the length is 4. So you know that you're referring to only the word long here, and you don't have to create a copy string or substring, something similar that we were able to achieve with a const pointer also. Okay. Include versus import. So we traditionally in C++, in the run up to till C++20, we have been doing a hash include of headers, which actually textually includes the header files. Okay, you should favor the C++20 import over this, where I don't know exactly what is the name of this header of the importable module. They call it modules, but modules are pre-compiled packages with the compiled binary kept for later use. The compiler manages this, and if you just say import memory, it is compiled only once and not every time. So if you see on the left hand side, if you have a very commonly used header like memory, you would include this 10 times in the compilation of a translation unit, and it will be textually included 10 times, it will be parsed 10 times, and duplicates will be eliminated by the compiler. This is a lot of work that we are wasting in order to and spending our build time and our developer time, and we are having lots more coffees than we should have in the time that it takes to compile. Excuse me. So you should take the smarter option of doing an import and not an include. Okay, here the pre-compiled binaries will be used. Only the advertised constructs will be visible out of the import, out of the imported module, and excuse me, and you cannot use constructs which were created inside the module, but they are not publicly available outside. So there are mechanisms to specify what is available, what is exported from the module, and what you can see from outside, versus what is internally created just for better constructs. So you create, let's say, lots of helper functions. It will be included in the textual include on the left hand side. But if you just created some helper functions which don't mean anything to, which are not, you can just be sure that those are not going to appear here, they are not going to be parsed, and they are not going to be interfering with anything else. All right, so save lots on compilation. Use modules. This can be a talk in itself about modules. No macro interference. So the problem with hash includes was if you did a hash define like we have. So I've seen some people do unit test with this kind of a hash define on the bottom right, define private as public. So now you can UT the class only for UT purposes. But if you have something like that, inadvertently you are also going to affect any hash includes after that line. And so even in the standard library now you will have some interference from, it is so easy to break, right, from outside. So you don't have those problems in the modules. Modules are exporting only what you have. Macros do not affect it. So these are some very good mechanisms to ensure your own sanity and saving a lot of time on build and coffee. Do take breaks though. Okay, then we go into the realm of new delete. This has been with C++ ever since. So you have to make sure that you delete everything that you knew, right? So let's say you have a function called as setup an interview, where the return is an interview pointer and you have a referral going into it. Okay, so you have some lead from somebody. So you create an interview, you want to return it, so you want it to stay. It cannot be on the stack, it cannot be a local variable, and you return it, right? Then you see that whether there are any vacancies. If there are no vacancies, you don't have to do anything, you just return a null. Then you try to do something. These are things that may throw. So you have it in a try loop, a try block. Okay, so you try to find the vacancy based on the skills of the lead. You try to schedule based on the panel. Okay, and you then have an interview maybe at the end of it. But because we said it could potentially throw, we should be ready to catch. And essentially we don't want to do anything, so really we don't want to catch. But as you see at this point, there is a leak except for the happy scenario. If you were able to set up an interview, you would return it. In other cases, you're not returning anything. So we need to make sure and remember to add the delete every time you're returning. And no, please don't start recommending that recommending against early returns. It's an anti-pattern. Please return as soon as possible if you can. And so you would have to delete the instance here where you checked something and returned early, where in the catch where you caught an exception and you made sure you wanted to clean up. Okay. But what if instead of a type pointer, you used unique pointer? This slide, it was not getting automatically deleted. We know unique pointer helps here. So if you have a unique, instead of, so this can cause leaks. Okay, I'm just repeating, just reminding you what you had. So we had to delete the P, and even in the usage where it was being returned as a pointer, does the user own this memory? Should it delete or should it not delete is the question in the minds of the user. And that again is not clear. So you want to communicate clear semantics of whether you own this memory or not. So you want to change that function to actually return unique pointer instead of just a pointer. So you know that ownership is contained inside this pointer, the pointer returned. Okay, you have an interview, you create it, now you do early returns, no problem. Uh, you return the unique pointer, no problem. If you just return a null PTR, like you had done in the previous slide, even if it is a unique pointer, it will be auto constructed, it will be default constructed with a null PTR. And this interview which you created instance, this will be destroyed in the local copy. Okay, so no problems, you are just not going wrong. Exceptions always clean up, and return ensures ownership transfer. You are saying what you mean. Okay, just return the interview. All right. Okay, so with the unique pointer, we saw this just previously a little quickly. We have two parameters to the unique pointer. Did you guys know? I guess we already had a slide, but it not only takes the type T, but it also takes a deleter type. And that handles how you delete the resource. So this is what the standard library would have in terms of the way unique pointer is actually defined. It has two parameters, and by default, it is doing a default delete, which is going to call a delete on the type T. Okay, but if you have something which you're of your own, you are allocating and deallocating your own memory, you are doing malloc and free or something of your own, you want to be able to use the unique pointer. It's very easy to do. You just say unique pointer. Okay, pardon me, I have not qualified the data type here with the type of the deallocator, but you know what comes here, decltype, right? Decltype of deallocate. Okay, so you have a unique pointer of employee, which is going to be deallocated with the decltype, with the data type of deallocate, and you allocate it and provide the deallocator to it. Okay, this allows you to do other smarter things like the file pointer. So now you're able to deal with your own memory management. You are able to deal with file pointers. You are able to deal with any other ways of creating ways of dealing with memory. Okay, with the core construct, with the std construct. Now, if you just have a pair, I'm just pointing out how the new is also a problem. New is still a problem the way we had in the previous slide, where we were creating a new unique pointer and we were immediately passing the allocation to it. But it also has a problem. So if you have a new way which is dealing with a pair of two pointers, the way to use it would be create a new A and new B, and you create the pair. But what if either of the constructors throws? Now, we know in C++ that you have to evaluate all the parameters which you pass to this constructor, which you pass to this function, which is a constructor in this case. You have to evaluate all the parameters upfront, either from left to right or right to left, in any order which is compiler specified. But you have to evaluate them before you can start calling the function. So if the function is taking a pointer and b pointer, you have two allocations. If the second allocation throws, you have no grip on the first allocation. You have no way to clean up the memory there, and this is going to be a memory leak. So what do we want? We want the pair to be using a unique pointer, and we pass in the constructor, which directly we immediately want to give to the unique pointers. We pass the new A and new B. But is this any better? It's actually not. We still have the problem where the caller may allocate and the second allocation may fail. So even if you have unique pointers, the allocations are still going to be evaluated in the calling context, not in the called context. In the called context, you will immediately put it in the unique pointer, so it does not help. So now you want to accept the unique pointers and move them into your members. Okay, it's much better. Now you have asked for the unique pointer to be created in the calling context. Okay, so this is what effectively will happen. Okay, if you write new A and new B, At this point, it's not, if the second one throws, it's not going to be any better, because the constructs of the construct of the constructor of the unique pointer which the parameter needs is a called construct, and it won't help. So it won't help, because if the second constructor throws, that unique pointer, which is a temporary, which you have to create. Here I have created the unique pointer in the local context. This will be safe, but if you just pass new a and new b, it will again not be safe, because you have uh, the data type of unique pointer in the called space. Okay, there is an article by Herb Sutter, the chair of ISO CPP committee. His article number 102 refers to this problem. You might want to go back and check. I should put a link to that. So the best way to do it is functions. If you execute a function, that entire function internally will execute fully and then come back. This is a very good situation to have, because what we want is we want to pass the creation of the unique pointer inside the function. We pass an a, sorry, I think our constructor was not taking anything, but if you wanted to pass something, you could have passed it here, and it would call the constructor of a with the passed elements. And inside that, it will be totally safe, exception safe, even if the second constructor, even if the second make unique throws for some reason. Okay, so you have a make unique function in standard to solve this problem. We don't come across this often, but when it does, it really hits you, and debugging is such a big problem. Okay, so always use make unique with your unique pointers instead of actually doing new yourself. So the recommendation of modern C++ is do not use new and delete, naked new and delete. Okay, it's going to crash again. Okay, so just like you have the unique pointer, we have shared pointer, and the shared pointer also has similarly a make shared function, which you should use to allocate objects. Now, shared pointer inherently means that it is shared, so many people own this memory together. Many pointers may at a time own this memory, and the person last releasing the reference would actually free up the resource. Okay. So this is something that was covered in some of our past sessions also. So no naked new or delete in code. This is a strong recommendation from modern C++. So if you are writing new and delete, consider bettering things. Okay. Now this section, I'll have to be quick in favor of time. Just like we had the new delete problem, where whenever you nude, you have to delete. You have, if you have the mutex, I have no option but to wait. If you have a mutex for critical sections, you have to make sure that you actually unlock every time you do a lock. Okay. And there, the code that you don't see, we are back in our function from before, where we were just setting up an interview. We are just sticking with that example, and instead of doing a new, where we were doing a new data type, creating a new for what we were returning, if we just have a mutex lock. So I'm just reminding you of this function that we previously had, and we had the problem with delete. So if you have a critical section here, in case and you want to guard it with a mutex, you do a lock, and then again you run into the similar problems like we did for the delete, that you have to remember to unlock every time you return from the function. So even at the end, you have to write an unlock before you return. In the catch clause and even in the if return early return clause, both these places you have to write unlock. Only then your program is really correct at this point. So as you see here, this is the same function as before. All I'm saying is you have a critical section here where you have to lock the mutex, and just like the new delete, you had to unlock every time you locked in all of those places. I hope you remember this construct, and you have to unlock it at the end also. Okay, this is doing it manually, and unlock and lock love each other. They must always be together, but really this is not the best we can do. So in order to eliminate mutex.lock, we have a lock guard. It is a RAII construct where you had this code before, and I had lovely animation. But yeah, so we have this code from the previous slide, which would then change to a lock guard here. So the only line which is changed is here. So you have a lock guard, which on its constructor, in its constructor takes a mutex, and mutex is locked in its constructor. Okay, if the mutex is it's unable to lock, it will block till it is able to lock the constructor. So it is just like lock, and so it has its constructor in lock. And like for any local variable, the moment it leaves the scope, the curly brace close, it will destroy, and in its destructor it has the unlock. So now we don't have to do all these explicit unlocks. All we can do is just be sure that lock guard will 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 keep our back. Okay, that was the slide. Okay, lock guard will watch our back, and it will actually deallocate. Sorry, it will actually unlock the lock. Okay, so if you see that entire function is now only this much. You don't have to do any of those manually. You just create a lock guard with the mutex. You check the vacancies. You early exit. You have a try catch loop. So the animation would have shown in the previous one that you don't even need the catch because you don't want to do anything with it. In the catch, we were just rethrowing the same exception. So we don't even need the catch. If this throws, we don't care, the caller will handle. We don't have anything to do in this function. So this function becomes so small and straightforward, just the code that it must have. And every exit from this function is guarded by the lock guard. It will definitely unlock. Okay. So, dealing with mutex, unique lock, scope lock, all these constructs is a session in itself. I invite any one of you, if you would like to present on these. I'm just presenting the core essences. This is for you to have enough, a thought should occur to you when you are doing this kind of coding, that you can go back and check these constructs. Okay, so lock guard is RAII. So if you have a transfer happening, you have a transaction mutex in order to do the transaction from to to. Okay, the parameters are missing here. But if you have this transaction happening, you can lock the transaction mutex and do the critical section here. You can do the validate before, you can do the conditional outputting section later on, but the critical construct, by creating a small local scope, you still have the construct which is working with local guard, and which this scope delimited construct is enabling. Okay, then we have something called as unique lock. If you want to transfer ownership of a lock, you have unique lock. Just like unique pointer is able to transfer ownership, but not let two pointers own the memory. Similarly, you have transfer of ownership. So if we have a unique lock, so ideally the from is a bank account, to is a bank account, and if you are transferring, you want to lock both of them and not want to change each other. The transaction lock in the previous slide was like only one transaction can happen in the system. That is very restrictive. Fake examples, but realistic enough for you to relate to real scenarios. So here you have unique lock where you say, I will lock it in a deferred way. This is a tag which you pass to the unique lock, which says when to lock. So it is not going to lock on construction. It just holds the mutex. It just knows of the mutex. So you have the from account and the mutex for it. You have the to account and the mutex for it. And both lock 1 and lock 2 are unique locks, which you pass to an std lock, which really locks them in order and by using these two locks. So at this point, these two LK1 and LK2, after that, after passing to lock, they won't be having the locks here. They will be passed inside to the lock, and in fact they will be locked inside there. Okay, and you can do the critical section work here. Again, it is guarded by scope, so the moment you leave the scope here, you are clear that you are releasing both the locks in the right order. This is to prevent deadlocks, right? Your deadlocks, if somebody locks one and locks two instead of locks two and lock one, so you would have this kind of a condition. Okay. Similarly, you have a scope lock. Now, scope lock is an enhancement, next step from beyond lock. So in scope, you just pass to it multiple mutexes. This is a similar example from the previous slide, but you don't have to do things yourself. You just pass two mutexes to it, and it internally just does a lock on its construction, and it will order in an order. It will lock them both. It is equivalent to the last screen. Okay, so these are the kind of things which things that love each other, things that just supersede each other, and these are the kind of things that you should use, the kind of decisions you should make in your code base in order to have better health of your code base, shorter code base, straightforward implementations, code base which expresses intent, and uses modern constructs which are much more safe and type safe and logic safe, no memory leak safe in real life. So with this, I would just say wish you all a very happy Valentine's Day, and we can all do with more love and less hate. Go with the right choices.